Hello everybody. Today I'm going to walk you through an AWS architecture that I recently recreated based on a project that I did during an IT internship last summer. Basically the idea is the team I was working on had some internal data that needed to be accessed by people over the public internet. But before they could access this data, we needed to authenticate them based on the username and password that they sent us via an XML API request. And then if they were authenticated, we then had to authorize that that particular user was supposed to have access to the resource that they were trying to access. So I'll kind of give you an overview of the architecture here. Down here on the bottom is kind of the main part of the architecture. So the user sends a request to an API gateway and API that I created, and that request is then forwarded to Lambda, which I wrote in Python, and that Lambda function parses the request and extracts the username, password, and the resource that they're trying to access. It then extracts the record from this encrypted DynamoDB table with the proper username, and it sends back the username and the encrypted password that user has, and it then decrypts that password and checks if it's the same as the password received in the request. If it's not, then the request is rejected. If it is, the user is authenticated, we then move to step 2, which is seeing if that user is supposed to have access to the resource that they are trying to access. And to do that, basically we go over to this secondary DynamoDB table and extract the record with their username. And each username has a secondary field with a list of the resources that user is trying to access. And those resources are basically comma separated values. So I parse that and see if that resource if the resource they're trying to access is in that list of resources that they're allowed to access. If they aren't, the request is rejected. If they are, then the payload of that message, of the request that the user sends, is sent to, in our case, it was an on-prem endpoint. It could be anywhere. It could be on a public cloud or wherever. And the software there does whatever the user needs and sends a response, which goes back through Lambda, back through your API gateway, and eventually to the user. So that's all great, but before we can do any of that, the user has to be created, username and password rather. So to do that, rather than sending me an email or whatever with what password they wanted, set up an ephemeral API gateway and Lambda function here, so that the users can set their own usernames and passwords. Basically, they just send an HTTP request to an endpoint, which goes to API gateway, which forwards the username and password to a Lambda. And the Lambda function then checks if the user is already in this database here. If they are, then it just updates the user's password. If they're not in the database, then a new user is created with that username and password. The Lambda function also does all the encrypting for the user's password using key management service, which isn't on this diagram. But yeah. So, and also, just to note again, this part of the architecture where the username and passwords are set, that I only made available for 1 or 2 hours during the project, and basically told all the stakeholders that they needed to set their username and password during that time frame, because obviously it's very insecure to just have this basically a public gateway to set and change passwords. So that it's only open for 1 or 2 hours, and then if it needs to be reopened in the future, that can easily be done. So yeah, I'll walk you through this top part of the architecture first, and then we'll go through the bottom part of the architecture. Alright, so here we are in API Gateway. I created a basic API and API gateway. There are loads of tutorials if you've never done it before, but I'm just going to briefly show you what I did. I just made a resource called a request and set its get function. And I believe the only thing I changed in here was in the integration request. I set integration type to a Lambda function, and the name of the username and password setting Lambda function right here. And then down here where it says body mapping templates, scroll down, I created application/JSON, and this document just describes the parameters of a URL request to this endpoint. So we're going to have something called username and something called password, and we want those to map to the username and password parameters of the API call, and these will be passed to Lambda function in the form of an event. And that's pretty much everything on this API. So if we go over here, oh yeah, I just wanted to show you all that there are currently no users in our, and this is the encrypted DynamoDB table, the authentication database. So we're going to add some users here. And here's the Lambda function that I wrote. Here you can set API gateway to be its trigger, or where you can see that it was set to be its trigger. I did it from the API gateway console, and you can also see that it outputs data to DynamoDB. So this is Python 2.7, and I'll post the link to this code in the description. I'll host it on my GitHub page. So basically here I've got an encryption function that uses KMS, Amazon's managed key service. I'm not going to go through every line here, but you can just kind of see event is where the information from API gateway is sent. So we've got a password and a username, and this is the name of my DynamoDB table. Sorry, that's actually the name of my, that's the alias for my DynamoDB table. Alright, so yeah, we just encrypt the password here. We attempt to get an item from the table with that username. If the item already exists, so the user already exists, then we just update that user's password using update item. If it's a new user, then we create a new item using put item, and then just double check to make sure it's there for good measure. There's a decryption function, which I don't actually use here, but I think I use it in the other Lambda function, but I put it there just for testing purposes, basically. Alright, so there's the Lambda function, and the one great thing about this is it doesn't require any packages to be zipped whenever you upload your code, so you can edit everything right here in the editor. Boto 3 and Boto Core are obviously part of AWS, and Base 64 is also included on Lambda servers. So we can test this. Get a good URI here. I'm going to paste this URI. So this, let me show you here. So if you go, after you deploy your API, which you do actions deploy API whenever you're ready. If you go to stages, prod, and then to your GET request, this is the URI that you use. And then after the URI, you just have a question mark and then your parameter name, so username and password. I just made a user with the username of test1 and a password of test password. Really creative. So I'm just going to click enter here, and function succeeded. Alright, so that should mean that when we go back to our DynamoDB table, there should be a username that says test user and some encrypted password that represents test password. And there we go. Test user 1, password, blah, 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 something. It's whenever we decrypt it, it'll be decrypted back to test password. All right, so there we go. We just added a user. Great. So that's the top half of our architecture here. Now I'll show you the bottom half. So starting from API Gateway, this is literally a clone. You can actually clone an API and name it something else whenever you start out. So I just cloned the first API, and then I just all I did was changed the Lambda function to the primary Lambda function that we're going to use here, which will be the authenticate, authorize, and forward the request function. And then here in body mapping templates, again, application/JSON, we just have one parameter called message. And the reason for that is on the team I was on, they didn't want the third parties basically just had one message that they were used to sending in XML format. So basically I'm just taking that entire XML message that they were sending so they don't have to change anything, and then I'm parsing that for what we need. And that's pretty much everything here. You can see in DynamoDB, I went ahead and created a user called test user 1, which is what we created in the other table. And there are two allowed resources, so test user resource 1 and test resource 2. Notice there's a comma in the middle. That's necessary in the way that I programmed it, because my Lambda function will parse based on this comma and separate the resources out so it can check if the user's desired resource is in its allowed resources list. Alright, if we go over here to our other Lambda function, you can see here kind of the architecture. There's API Gateway. Every Lambda function writes to CloudWatch logs as far as I know. And then we're also interacting with DynamoDB. Two DynamoDB tables actually, one for the, as you can see here, two DynamoDB tables, one for the encrypted passwords with the unencrypted username, and one with the username and their approved resources. So let's quickly walk you through this. There's our decryption function. It uses KMS to decrypt the string that we're pulling from our encrypted DynamoDB table. Alright, we've got our two DynamoDB tables here, the authorization and the authentication tables. Here we extract, let me show you a sample message if I can here. So like a message, it's XML, so this is kind of what it looks like. So here you see question mark and then message equals, and then this is the message that the user's sending. So I'm just parsing that. Oh, whoops. Okay, so I'm just parsing that to get the message here. Okay, so yeah, the message coming from the event, the password, you can split along this, and that takes off kind of the first unnecessary part of the string, and that takes off the last two characters of the string. And the reason for that, if you go to password, so it'll split on test password, and then it'll take off that part and that part, so we're just left with test password. Alright, so then it does pretty much the same thing for username and resource. This is pretty much for debugging. The print statements. Alright, so once we've got all the information that we need, let's see, so here next step is, I guess the first step really is to authenticate the user with the encrypted DynamoDB. So first we try to get the item, and then we right here, so we extract the password from the table, we decrypt it, And it's in byte format whenever you decrypt it for some reason. So you have to decode it with UTF-8, and then you get the plain decrypted password and plain text. Print statements for debugging. So if the password from the table is the same as the password that the user sent us, then the user is authenticated. Otherwise, then return incorrect password. Oh, and then here, so this is basically checking if the user is in the table. So if the user is not in the table, return the user is not valid. All right, and then kind of the next part of our function here is getting the allowed resources from our unencrypted DynamoDB table. So we do a get item. We get the resources. You can see here how I access allowed resources, so you can kind of access it like almost like it's an array. So that'll get this information. So then I split on the comma, so that'll create two objects, one test resource 1 and the second one will be test resource 2, and it'll be put in an array. So then we iterate through the array, and if the resource that the user is trying to access is not in that list, then we say the user is not authorized to access this resource. Otherwise, we continue and we forward the user's request to during the project there was a special endpoint we used. This is a great just kind of dummy endpoint that I found. Thanks Postman. So that basically just echoes back all of the parameters that you send in. Pretty much just a placeholder used for testing. And then you get a success. Here's your API response, and there's the response from our dummy API. All right, so let's see this in action. Enter, and hopefully we get a successful request. All right, so success. So if you didn't catch that there, so there's our message. There's the username, test user1. There's our password, test password, and a resource, test resource 2, which is in our allowed list. And this is pretty much everything that the Postman Echo dummy API sends back. So it looks like everything worked. So I hope this was a helpful video for somebody. I know whenever I was working on this project, it took me forever to figure everything out. So hopefully this will make somebody's life a little bit easier. Like I said, I'll post the code in the description. And if anybody has any questions, just post in the comments and I'll do my best to answer. Thanks.